You know, there's way more to a ray of sunlight than meets the eye. I mean, way more. What we actually see is just this tiny sliver of a vast invisible rainbow, a whole spectrum of hidden energies that, it turns out, shape our entire world. Okay, let's get into it.
So, what is really hiding in the light? That's the big mystery we're unpacking today. And the answer? Well, it didn't just add a new chapter to the science books, it totally rewrote our definition of reality itself.
For pretty much all of human history, the rule was simple, right? Seeing is believing. If you couldn't see it, it just wasn't there. But it turns out our eyes are only catching a tiny fraction of this cosmic show that's happening all around us all the time. And the very first hint of this came from one surprisingly simple experiment.
So let's rewind the clock. We're going to go looking for those first clues, the first hidden colors that kicked off a complete revolution in how we see, well, pretty much everything.
Okay, picture this. It's 1799. An astronomer, William Herschel, is playing around splitting sunlight with a prism. And he gets this idea, what if he measures the temperature of each color? So he moves the thermometer through the rainbow, and yep, just as you'd expect, it gets warmer as he moves towards the red end. But then, almost on a whim, he slides that thermometer past the red light into what just looked like empty darkness. And boom, the temperature spiked. It was the hottest point of all. He had just found a form of light that was completely invisible, but absolutely undeniably real.
This invisible energy was eventually called infrared, which literally just means below red. And it might sound all scientific, but you feel it all the time. That comforting warmth that radiates from a hot kettle or a campfire? Yep, that's infrared radiation making itself known.
So, Herschel had found a new color at one end of this invisible rainbow. And naturally, other scientists started wondering, could there be something at the other end? Just 2 years later, a guy named Johann Ritter decided to find out. He used paper that was coated in silver chloride, a chemical that, kind of like old camera film, darkens in the light. He laid out the spectrum on the paper, and just as he expected, it darkened. But here's the kicker. The paper turned blackest in the empty space beyond the violet light.
And there you have it, ultraviolet light, which just means beyond violet. The other end of the invisible rainbow was found. And just like its infrared cousin, you are very familiar with what it does. You ever get a sunburn on a cloudy day? Yeah, you can thank those invisible ultraviolet rays for that one.
So now we've got infrared on one side and ultraviolet on the other, two invisible bookends to the rainbow we can actually see. For a little while, they were just these scientific curiosities. But the real breakthrough, the big aha moment, was realizing they weren't separate things at all. They were just pieces of a much, much bigger puzzle.
Now this is the key to that whole puzzle. Scientists figured out that all light travels in waves. And here's a great analogy. Think of red light as a low, rumbling bass note. It's got long, slow waves. Violet light, on the other hand, is like a super high-pitched whistle. Short, fast, frantic little waves. And suddenly, it all just clicked. Infrared and ultraviolet weren't weird. They were just musical notes our eyes couldn't hear.
So here's the critical point. If light is just waves, are there other notes on the scale? Well, in 1860, a physicist named James Clerk Maxwell sat down and did the math, and his equations came up with this absolutely stunning prediction. He found that these electromagnetic waves weren't limited to the little slice we could see. Nope. They could exist at any frequency you could possibly imagine. It wasn't just an invisible rainbow, it was a vast, undiscovered ocean of radiation.
And this just brilliantly shows what happened next. Maxwell had basically drawn a treasure map for the scientific world, and a new gold rush began. Over the next few decades, researchers raced to find these waves he predicted. And they did. Heinrich Hertz discovered radio waves. Wilhelm Röntgen found X-rays. Henri Becquerel, gamma rays. They were filling in all the blanks on Maxwell's map, revealing the full, just breathtaking scale of the electromagnetic spectrum.
Okay, so that's a fantastic story of scientific discovery. But why does any of this matter to you and me today? Well, because once we could see this invisible spectrum, we learned how to control it. And in doing so, we basically built the entire modern world.
Seriously, just think about your day so far. That music you streamed on your commute, carried by radio waves. The lunch you're about to heat up in a minute, microwaves. That TV remote sitting on your coffee table, it uses a little beam of infrared light. We are literally swimming in an ocean of this stuff every single day.
And it's not just about convenience. As we move up the spectrum to those higher energy waves, the applications become truly world-changing. X-rays, with their uncanny ability to pass right through soft tissue, completely revolutionized medicine by letting us see inside the human body for the first time. And then, at the very extreme end, you have gamma rays, born from nuclear reactions, holding some of the universe's most formidable power.
Of course, with great power comes the need for some pretty great caution. The same energy that makes these waves so incredibly useful can also make them hazardous. So, how do we manage to wield all this power safely?
Let's just take ultraviolet light from the sun. We're always told how dangerous it is, right? But here's the surprising fact. In small doses, it's actually essential for us. Our bodies use it to produce vitamin D. The key, like with so many things in life, is the dosage. A little is good for you.
So the crucial question then becomes, what happens when a little becomes a lot? Well, as the energy of the waves increases, as you go from UV up to X-rays and gamma rays, so does their potential to damage living tissue.
Luckily, we've developed all sorts of layers of defense. The planet itself gives us the first and best one, the ozone layer, which filters out the most harmful radiation from the sun. Down on the ground, we can find simple shields like shade from a tree, or we can wear them, like clothing, which, by the way, is why light colors feel cooler in the sun. They're reflecting more of that energy away. And for the really powerful stuff, we engineer our own protection, like those lead aprons you wear at the dentist's office.
And speaking of wearable shields, here's a really critical number to remember for your eyes: 99%. Any sunglasses you buy should block at least 99% of both UVA and UVB rays. You got to think of them less as a fashion accessory and more as essential protective gear for one of your most important sensors.
You know, it is such an amazing story when you step back and think about it. It all started with a single thermometer, placed in a patch of darkness, showing this little flicker of unexpected heat. And from that one simple observation, we ended up mapping a vast invisible universe, one that we now use to communicate across the globe, to peer inside our own bodies, and to power the engine of modern civilization.
Ultimately, the story of the invisible rainbow is just this profound lesson. Our senses show us only a tiny sliver of the real world. We had to build new eyes just to see the rest of it. Which leaves you with one last, tantalizing thought. What other invisible rainbows are all around us right now, just waiting for the right tool and the right curious mind to finally bring them into the light?